Hello everyone, in this video I would like to introduce the chapter 3 random variables and probability distributions. So first let's look at 3.1. It's concept of a random variable. A random variable is a function that associates with a real number with each element in the sample space. For example, if you toss a coin, you're going to have two outcomes, the head or tail. So when you look at a random variable, it could be the random variable as denoted as x equals head and equals 1/2. Have that. The random variable could be the outcome of they toss a coin, or it's just any. The random variable is something it's not a thing for sure happens. Random variable is a variable first, okay? It's a function that is associated with a real number with each element in the sample space. Let's look at examples. Two balls are joined in succession without replacement from a urine contain 4 red balls and 3 black balls. The possible outcomes, the value of y, random variable is y, where y is the number of red balls. So you have 3 red balls. If you take out 2, for example, take out 2, it could be 2 red, 1 red, and another red and blue and red, or blue. So y is a random variable. You can say probability of y equals 1. For example, this one is the problem. You can do probability of y equals 1. This means what? This means when you pick up 2 balls, one of them is red, like that, okay? So you have a value associated with that number. Okay, so this is the second example. And well, in this whole section, you read all the examples. I think it's not really hard, or not hard at all. You can read all the examples. Then I would like to explain something about the discrete sample space and continuous sample space. So discrete random variables is something is countable. Okay, a discrete variable. Well, if a sample space contains a finite number of possibility that ending sequence with as many elements as there are whole numbers, called discrete sample space. Discrete sample space have a discrete variable is a set of possible outcomes is countable. Discrete, okay, it's countable. 1, 2, 3, 4, 5, 6. Okay. For example, when you have, like, just give you example, just the random variable of the number of the fish caught during a fish tournament. Okay, the number of something, or the number of the students in the classroom who passes class. That's a discrete. You can always count how many numbers. Okay, that's called a discrete variable, discrete random variable. Well, the continuous random variable is always measurable. You can always measure it. Continuous scale, like time. You can measure like when it's going to arrive, like arriving time. It's continuous. It's any time can come here, right? Or for example, the square footage of a house, you can measure it. It could be this big, it could be this big. So it's continuous measurable distance. So that's continuous, okay? Continuous is measurable. Discrete is countable. You can always measure it or use something to say how long it is, how big it is, like area, volume, time. Those things are continuous variable. Okay, you're gonna have an example in your homework. The first one is going to be discrete variable or continuous variable. So next one is discrete probability distribution. Discrete probability distribution. So basically, you're gonna have the first is for the set of odd pairs x and fx, the probability function. The probability mass function, you have a function, you have different. For example, the first one example, it give you m equals what? Okay, so the probability function first the probability is always bigger than or equal to 0. Okay, if it never happened, it's 0. Okay, if likely happens, sometimes we say 80%. So must be bigger than or equal to 0. You never see the probability is negative. Even if it doesn't happen, it's 0. Okay. Okay. So the second thing is, if you add all the probability together, it's going to be equal 1. If you add all the possibilities, equals 1. For example, for a person who okay, just say the weather. The weather tomorrow is going to rain. It's 30%. Not raining is 70%. You add those together, it's going to be 1. So you add all the possible outcomes together, it will be equal 1. Okay. The third one is for Px equals a particular number, small x, equals the probability function fx. Let's look at this example. A shipment of 20 similar laptop computers to a retail outlet contains 3 that are defective. So 20, you have 3 defective. Okay, just say defective. And you have 17 are good, right? Now, if a school makes a random purchase of 2 of these computers, find the probability that distribution for the number of defectives. So right now, they're going to choose 2 out of the 20. Okay, so it's going to be a discrete probability distribution because all the computers are countable, right? So if you buy 2, you could have this issue: 0 computer defective. Okay, 1 computer is defective. That's the it says distribution for the number of defectives. 2 computers defective. So that's all the possibilities. Because when you buy 2 computers, maybe both are good, one of them is not good, or both are not good. Okay, that's all the possibilities. So first, let's look at 0 probability x equals 0 means 0 are defective. 0 computer is defective means both are good. If you say both are good, the 2 good computer will be selected from where? From the 17. Okay, so 2 good, you have 17 good. If both are good, so choose 2 from 17. And you choose choose 0 from 0, which is 1. So choose 0 from 0, choose 0 from the 2, from the 3 defective. And the total probability is you randomly choose 2 from 20. That's how you do that, okay? Then you can use the formula to do that. It's equals, well, choose 0 from 3 is 1, choose 2 from 17 equals 17 times 16 over 2 times 1. The bottom is 20 times 19. You choose 2 numbers from the top, 2 numbers from the bottom, and then you find that it's going to be your final answer. You can 2 cancel out 17 times 16, 20 times 19, and you can use a calculator to do that. Okay, that's the probability for x equals 0. 0 computer is defective. Now what about 1 computer is defective? If 1 computer is defective, means you choose 1 from the good computers. So choose 1 from 17. You choose another one from 3 bad computers. Okay, and the total sample space, you just randomly choose 2 from 20. Okay, and then the answer is going to be 17 times 3. Because 17 times 1, 17 is the first number from the top, and divided by 1 is 1. And the bottom is still 20 times 19 over 2 times 1. Okay, you can use the calculator to do that. And then P x equals 2 means, okay, both computers are defective. It's really bad luck. Okay, now you choose 0 from 17 because none of the computers are good, which means you choose 0 from good computers, so 0 from 17. And you choose 2 bad computers from 3 computers, 3 bad computers. Okay, so that's your top. The bottom is a total sample space randomly choose 2 from 20. Okay, so the answer is going to be 1 times 3 and 20 times 19 over 2 times 1. Okay, that's how you do this problem. That's the zero probability is zero computer, zero defective computer. The probability you get is 0 defective. The probability you get a 1 defective out of 2. The probability you get both are defective. This is all probabilities, and this is the explanation of this problem. Okay, and you can look at example 3.4 by yourself. I don't think it's really hard. Well, I'm not going to explain that again. You can spend some time reading that one. And next one is the definition of commutative distribution function. Well, this means the commutative distribution function is you add like until some point is big Fx equals p x less than equal to x. Basically, you can add all the functions ft, and for x is less than bigger than negative infinity. Okay, what's the meaning of that? We still can take this one as an example. So I can change my question. What is the probability? What is the probability that you get at least one computer is defective? You randomly purchase 2. What is the probability that at least one computer is defective? Then you have to do px equals 1 plus px equals 2, right? You can't contain px equals 0. Then I can also change the problem a little bit more. What is the probability that no more than one computer is defective? This is no more than one computer is defective. That means px is less than equal to 1, and then you have px equals 0. None of the computer is defective, plus one computer is defective. Does that make sense? This is the kind of the idea of cumulative distribution. Is x less than equal to a fixed number. Okay. So you add the previous one, or always add the previous one. You can read this book, this page, and you just read it and see if you understand some those words. I think it's pretty straightforward, not really hard. Okay, this book is not designed really hard questions. You just understand the definition, you know how to do it. That'll be great. Continuous distribution, we're going to do more of the discrete distribution. We're going to do more, for example, binomial distribution. Continuous distribution, we're going to do more, for example, binomial distribution, exponential distribution. Discrete distribution, we're going to learn Poisson distribution in the future. We're going to learn continuous distribution, which will have gamma distribution, exponential distribution, normal distribution, and we also have beta distribution. So a lot of distribution we can discuss later in the class. But right now we want to know the basic definition of discrete distribution, discrete probability distribution, and a continuous probability distribution. Okay, the definition of those two different distributions. So continuous probability distributions is the continuous random variable has a probability of 0 to assume exactly any of its value. So basically, the variable itself is continuous variable. It's not discretized variable. It's a continuous variable. Then we have continuous function. So the probability is what we call the probability function a density function. Density function, you can see, is continuous. It's everywhere. It could be any point. Okay. Density function, for example, this one, the number c, we can easily tell Number C is pretty much like a normal distribution, bell shape, okay, and it's continuous variable. So if we have something like this, it is a uniform distribution. We'll probably have something like that in the later. This is a normal distribution. And the first one, picture A is pretty much like a gamma distribution. Okay, chi-square distribution. Is pretty much like chi-square distribution. We're going to look at the chi-square distribution later as well. Okay. Continuous distribution is the variable is continuous variable. Okay. So when you look at the probability from A to B, x bigger than A, less than B, we are going to take, because it's a continuous function, we have to add all the probability together. If you're talking about the adding or summation, is what? It's antiderivative, it's integral. So you take the integral from A to B and fx dx. Okay. When you look at the integration from the picture, it's going to be the area. It's going to be the area from A to B. Okay, the integration from A to B is the area from A to B, and that is the probability of x bigger than A, less than B. You add all the possibilities together. But if you say what is the probability of x equals A now at this point, at one point, well, this is going to be from A to A. You take the antiderivative. What's that? And it's going to have a big fx is the antiderivative of fx. And you plug A into A, and it's going to be fa minus fa, and which is 0. Okay, so if you're talking about continuous function at a particular point, is 0. Okay, if you're talking about probability, like it's going to be a range. If you 1 point, it's 0. Let's look at the definition. The function of fx is a probability density function. And for the continuous random variable defined over the set of real numbers, if the fx should be bigger than or equal to 0, that's for sure. Second, they take all the derivative from negative infinity to positive infinity, is all the probability together, dx equals 1. Okay. And number 3, you take derivative from A to B, so I have to write down probability x bigger than A, less than B, which is take the antiderivative from A, or integral from A to B, fx dx. Okay, that's the 3 properties or definitions of the continuous function. Now let's look at an example. The function fx is, suppose that the error in the reaction temperature in degree for a controlled laboratory experiment is continuous random variable x having a probability density function. So if I have the probability function is fx equals x squared over 3 and 0, negative 1 less than x less than 2, and elsewhere. Okay, this is a continuous function because f is a density function, it's a continuous function. So this is a continuous probability distribution. When we have something discrete probability, we always have something like this. X equals 1. I can always have something like this. Just put an X. X equals 0, X equals 1, X equals 2. You have the Px, okay, equals small x, big X equals small x. And it's 1/2, 1/3, like that. Okay, you add all. It's kind of a one by one. It's countable 1 by 1. You add all of them together, it's going to be equal 1, like that. That's discrete. This is probability distribution. Well, if you are talking about continuous distribution, probability distribution, is you give a function. Okay, give you a function. So first question is verify that fx is a density function. Well, a density function, if we look at the previous previous definition, we know that first we need to prove that. We need to show first fx is positive or non-negative. We have that. And x over square over 3 is positive because the square is positive and x belongs to -1 to 2. Okay. Well, second, we have to verify that from negative infinity to positive infinity, that is 1. But it's given, even you write down negative infinity to positive infinity fx dx, well, if you do that, because elsewhere, it only has value from negative 1 to 2. Elsewhere is 0. So this equals 0 plus. You only from negative 1 to 2 you have value. So it is 3x squared, x squared over 3 dx. Elsewhere is 0. So plus this one, let's see what's the integral. It's x cubed over 3, and the antiderivative is add 1 on the power, divide by the new power. So you have another 3 here. And plug in 2 and negative 1 into the integral. It's going to be 8 over 9 minus negative 1 over 9. So the whole thing equals 1. Okay. So then we prove that. We also prove that from negative infinity to infinity, this density function equals 1. And we showed that first, this function is positive. Fx is always bigger than equal to 0. Second, from negative infinity to positive infinity, this function is equals 1. Take the integral equals 1, which means all the possibility together equals 1. Okay. And also next is question B, is find the probability of p from 0 less than equal to x less than equal to 1. Even you don't equal 0, we put a 0 here, it's okay, because we just said at one point it does not really matter, because at one point the probability is 0. Okay, so you can do contains 0 or not contain 0, as it doesn't matter. And also the probability is going to be just take this integrate from 0 to 1 and 3x squared and dx. The antiderivative is x cubed over 3 times 3. We just get that, and from 0 to 1, which is plug 1 into here is 1 over 9, plug 0 into here is 0, so the answer is 1 over 9. That is your probability of x is bigger than 0, less than equal to 1. Okay. And the cumulative distribution is just take the antiderivative, take the integral. If I have a fx, this is just to take the antiderivative from negative infinity to x until x, because it's px is less than equal to x. Okay, and this equals that. Less than equal to from negative infinity up until this point. Okay, the integration of fx. Okay, so I think that's really easy question, and we can look at the example. Still the same example. We want to find out the fx, big fx for the cumulative distribution fx, big fx for fx equals x squared over 3. We want to find the big fx, so we do fx equals, take negative infinity to x, to small x. S to small x for here. Okay, and then ft dt, so is going to equals negative infinity to x squared over 3 t squared. We just want to use a different notation, make sure it's not exactly the same variable, get confused. Ft dt, ft is a density function. You can see the density function could be just ft equals t squared over 3. That's fine. Okay, and then you finish that, it's going to be, you find that is t cubed over 9 plug it says evaluate a negative with the value from 0 to x to 1. From 0 to x to 1. Oh, I think that's just what we need. Just the x over 3. No, over 9. Okay. And you can do, let me see, it's x cubed plus 1. Oh, if it's take a negative 1 until that, and because it starts from negative, it starts from negative 1, sorry, negative infinity. So this equals because it told you that it's from -1 to 0. After -1 is always elsewise 0. So it's 0 plus -1 to x t squared over 3 dt, because from -infinity to -1 elsewhere is 0. Okay, so the whole thing is going to be 9t cubed. Plug in -1 to x, so the whole thing is going to be x cubed over 9 plus 1. That is your cumulative function. You can look at the next problem yourself. That's the continuous function. And I think we can stop here for today. And if you have any questions, just send me an email